This lesson is find the coordinate vector. We represent coordinate vector in bracket and subscript big B of x relative to the given basis. And that basis could be as many as it wants to. So again, coordinate vector is represent in bracket subscript B. And given basis could be any basis from B1 to as many as it wants to. So here in our example, we have two bases, B1, B2, and X. Now we put them together as one matrix. Put this vector, this vector, this vector in one matrix. And now we do row operations. Now if you look carefully, how it is written on the left side here, we put B1, B2, Bx, put them together as one matrix. Now we need to do row operations. So this is a 1 already, so we are good. We just leave all alone. Okay, we leave it alone here, here, and also here, and also here. Leave it alone. We need this -2 to be a 0, so put a 0. Okay, so we need a -2 to become a 0. So opposite of -2 will be +2. So 2 times row 1 plus row 2. So 2 times 1 will be 2, subtract 2, 0. 2 times 5 is 10. 10 subtract 6 will be 4. 2 times 4 gives me 8, plus 0 gives me 8. Okay, again, we need this -2 to become a 0, so we multiply the opposite of -2. Next, we want this 4 to be a 1, so we will multiply the reciprocal, which is 1/4 to row 2. So 1/4 times 4 gives me this 1. 1/4 times 8 will give me this 2. Next, we need this 5 to be a 0. Okay, it's because we have something in the pivot position, and since it is a 1, we need this to be a 0. Okay, so to get this to be 0, which I have over here, do the opposite of 5, which is -5. So -5 times row 2 plus row 1. So -5 times 1 will be -5. -5 plus 5 gives me 0. -5 times 2 will be -10. -10 plus 4 gives me -6. Once this is done, we are completely no more row operations. And how do we know we are done? When I have 1, 0, and then 0, 1. Okay, that's when we are done. Now all we have to do is just write out our answer. So this is x1 equal -6, x2 equal 2, which I have here. One more time. How do I know when we're done? When I have 1, 0, 0, 1. So the first x1 will be -6. Second x will be +2. So this is our coordinate vectors, which is -6, 2. Now you can check this to see if it's true or not. So we can go back. So this is how you would check. So -6 times 1 will be -6. 2 times 5 is 10. -6 plus 10, +4. Okay, so that's how you check. So let's do the second row. Let's see if it's true. -6 times -2 gives me +12. 2 times -6 is -12. +12 subtract 12 gives me 0. So this coordinate vector is the solutions for base 1, base 2, and this x vector. Okay, so that is a 2 by 2. You do the same thing with a 3 by 3. All right. So same thing, base 1, base 2, base 3. So base 1, base 2, base 3. And this is our x vector, which is here. Put all of them together as one matrix and do row operations. Okay. Now, if you notice, we already have a 1. So 1 right here. So now we need this -1 to be a 0. We need this -3 to be a 0. So opposite of -1, +1. Opposite of -3, +3. And you will do that for row 2 and row 3. So 1 times 1 gives me 1. Subtract 1, 0. 1 times 3, -3 is -3. -3 plus 4 gives me this 1. 1 times 2 is 2. 2 subtract 2 gives me this 0. 1 times 8 is 8. 8 subtract 9 gives me this -1. Repeat that process for row 3. 3 times 1 is 3. 3 subtract 3 gives me 0. 3 times -3 is -9. 9 plus 9 gives me this 0. 3 times 2 will gives me 6. 6 plus 4 gives me this 10. And then 3 times 8 will be 24. 24 plus 6 gives me this 30. Okay. Next, if you notice, this is already a 1, so we're okay. This is a 1, so we also okay. Now we need this pivot position to be a 1. So multiply the reciprocal of 10, which is 1 over 10. Okay. So we can do this. 1/10 times 10 gives me 1. 1/10 times 30, which gives me this 3. One more time. We need this to be a 1. So multiply the reciprocal of 10, which is 1/10. So 1/10 times 10 gives me 1. 1/10 times 30 gives me 3. So now, if you look carefully, this right here is a 1. Above that 1, we have a -3. We need this to be a 0. Okay, so above this 1, we need this -3 to be a 0. So we got to get rid of that. So we will do the opposite of -3, which is +3. So 3 times row 2 plus row 1. 3 times 1 will be +3. +3 subtract 3 gives me this 0. 3 times 0 plus 0 gives me 3 times 0 is 0. 0 plus 2 gives me this 2. 3 times -1 is -3. Plus 8 gives me this 5. Okay, so this column I have 1, 0, 0, so we are done. This second column I have 0, 1, 0, so we are done. However, the last column I have a 0 here, which is good, so we don't have to worry about it. Now we need to worry about this 2. We need this 2 to become this 0. So the opposite of +2, -2. So -2 times row 3 plus row 1. So -2 times 1 will be -2. -2 plus 2 will be this 0. -2 times 3 will be -6. -6 plus 5 gives me this 1. Now we are completely done. No more row operations because we have 1, 0, 0, 0, 1, 0, 0, 0, 1. These pivot position should be all 1. These spot right here should be all 0. That's how you know when you are completely done. So now we just write it in coordinate vector. So x1 is -1 right here. x2 equal -1, which is here. x3 equal 3, which is here. So this is our solution to this matrix right here. Again, you can check and see if it's true. So very easy. All you do is just take this -1 times 1 is -1. -1 times 3 will be +3. Okay. And then 3 times 2 will be, so -1 times -3 will be +3. 3 times 2 will be 6. So +3 plus 6 will be 9. Subtract 1 gives me this 8. One more time. -1 times 1 is -1. negative 1 times negative 3 will be positive 3. Negative 3 times 2 will be 6. So 6 plus 3 will be 9. Subtract 1 gives me that positive 8. Okay, so same thing with the second row and the third row as well too. So negative 1 times negative 1 plus 1. Negative 1 times 4 is negative 4. 3 times negative 2. Okay, so 3 times negative 2 will be negative 6. Okay, so one more time. Negative 1 times negative 1 will be positive 1. Negative 1 times 4 will be negative 4. Okay. And then 3 times negative 2 will be negative 6. Okay, so I have negative 6. Okay, so negative 1 times negative 1 will be positive 1. Negative 1 times negative 4 will be negative 4. So 1 subtract 4 will be negative 3. 3 times 2 will be negative 6. So negative 3 plus negative 6 gives me negative 9. One more time. Negative 1 times negative 1 will be positive 1. Negative 1 times 4 will be negative 4. So 1 subtract 4 is negative 3. 3 times 2 will be negative 6. So negative 3 plus negative 6 gives me negative 9. Okay, so same thing with the bottom as well too. So here we go. Negative 3 times negative 1 times negative 3 become positive 3. Negative 1 times 9 is negative 9. So 3 subtract 9 will be negative 6. 3 times 4 gives me positive 12. Negative 6 plus 12 gives me positive 6. Okay, so we know that this is true for this matrix, and we did earlier on the top that this vector is also true for this matrix. Okay, so this is how we find the coordinate vectors, and this is how we write coordinate vectors in bracket x subscript b.